From Chicago, welcome to 3Degrees Discussions. I'm your host, Mike Vasquez. This is a podcast devoted to the stories behind the innovators, entrepreneurs, and leaders in the 3D printing industry.
Even in the chassis, there are parts where, say crash worthiness is a main concern, whereas other areas, say stiffness, where like the A pillar or B pillar, stiffness is more of a concern. Everything is essentially boils down to dollars per kilogram. And we have a way to convert basically how much power it takes to operate a process parameter that could give us ductility or crash worthiness or high strength. And like both sets of parameters have their own cost per kilogram. And the same idea, same logic goes into materials. If we have a PSD, a particle size distribution cut, that could give us, results that are favorable for one parameter. We categorize that as something like a factor per dollars per kilogram. So those things go into our large trade, manifested in a spreadsheet, and we essentially calculate the cost per vehicle in that manner.
That was Simon Pun. Simon is a materials engineering leader at Divergent 3D. Divergent replaces conventional vehicle architecture, tooling, and related factory assets with a proprietary patented end-to-end system for vehicle design and volume manufacturing. Their mission, enabled by additive manufacturing, aims to produce significantly lighter, higher performance, safer, and lower cost vehicle structures. Simon joins the show to discuss how 3D printing can revolutionize the automotive industry. Great to have you on the show, Simon. As we begin, why don't we just have you introduce yourself and what you're up to now?
Yeah, Mike, thanks for having me on the show. Very honored to be here. My name is Simon Pun. I am currently the materials engineering leader at Divergent 3D. I began my journey at 3M, where I worked on the binder jet technology, and at the time we're looking to revamp a Z Corp, one of the early days printers, to sort of refurbish that machine to print with 3M's proprietary ceramic material to make dental applications, and also helicopter shields. I thought that was a pretty interesting project. And then I went on to grad school to study powder metallurgy, specifically in aluminum, magnesium alloys. And then I started working at Aerojet Rocketdyne, supporting the AR1 booster engine program. And at the time, it was pretty exciting because I thought, after grad school, it was like, oh, this is the modern day space race. At the time, Aerojet was competing against Blue Origin's BE4. Which both rocket engines have a ton of 3D printed parts, primarily the MLS printing technique. But also worked on the RS-25 engine program supporting NASA's Space Launch System. Recently, I saw a picture that it's being installed at the Stennis test stand. So I thought that was pretty cool. But yeah, that's my little brief journey. I've been at Divergent for almost 4 years now. One of the early employees, and I've seen a lot of growth with the companies and wear many hats.
So for those who don't know what Divergent is, do you want to give them a little bit of a a background?
Yeah. Divergent essentially now is considered a late stage startup company that has developed and now optimizing a new structure or structural manufacturing platform to enable cost savings in automotive manufacturing. Um, one technical pillar that makes cost savings possible is additive manufacturing, which effectively eliminates the traditional large tooling investment many automotive OEMs would experience. Um, and as a technology demonstrator in 2017, we printed the world's first hypercar called the Blade. And because of the press that or the positive feedback that we got from the press and um, actually customers and car dealerships coming up to us and say, hey, can we buy one of these things? Um, one of these blades. We recently actually kicked off a subsidiary company called Zinger Vehicles. If you search that on Google, you'll find a pretty nice video of our CEO driving, the what we call the 21C vehicle. And it has some crazy spec. I'm not a big car guy, but apparently that is a vehicle to compete with the McLarens and the Bugattis in the world.
And so is the idea with Divergent to kind of print entire vehicles and Zinger as well, or is it to kind of pick out specific applications, whether it's a type of vehicle or type of part that additive or other advanced manufacturing technologies would be well suited to process?
Yeah, so with Divergent, the mission is to provide a platform for printing the entire frame or the chassis of a vehicle. But there are also other parts if it makes sense for a light saving perspective to print, we also do that.
Got it. And in terms of scale, those must be pretty large parts. Are you doing mostly DMLS or a variety of technologies?
Yeah, right now we have a strategic partnership with SLM Solutions. So we use the biggest machines that they have, and we print using like the MLS technique, these large parts, and then we would join them using proprietary joining techniques to eventually create the chassis.
And so, with your role as kind of a materials lead, what sorts of kind of materials challenges do you see in the space? I mean, typically when we think of cars or lightweighting or even aerospace, you've got some titanium, some aluminum options, but those alloys and specific metals may not always line up to what a conventional car company might be used to using in their vehicles.
Yeah, one push from the industry, and we talked a little bit about bringing insight from Industry 4.0. The multi-material chassis system is being pushed forward, and that's something we are also heavily invested in. So printing different materials and joining them together to get the most optimized vehicle is what we're doing. You mentioned the challenges with the alloys and what's printable and what's not. I think those experienced and been in the field for a little while know that if we want to print aluminum, normal off the shelf, say 6082, 6061, are not so print friendly, and they're in the art. Many companies and research groups have tried to manipulate material to make it printable. So we also face the same challenge in order to get high performance parts. We have we're scratching our heads right on what can be printed. So as an effort to sort of unlock the aluminum alloy for our vehicle, we invested in creating our own aluminum materials, as well as purchasing being early adapters of some of the research companies in the field, and purchasing their alloy and testing with our geometries and see if they work.
And in terms of vehicles, certainly safety and quality is a big concern. Can you talk a little bit about what's your thought process and approach to designing kind of experiments or testing some of these new materials that you might be sampling from different entities in the materials development space?
Yeah, coming from the aerospace industry, there isn't what I would imagine like the TRL, the technology readiness level, or the manufacturing readiness level in automotive. From my experience, we deliver what the customer asks us to do, and to show that our material is meets the safety requirements. So there's the SAE board with the regulations and the specifications that we gotta meet. So ranging from crash testing, corrosion testing, but because 3D printing materials and structures are quite new in the industry, we oftentimes get separate and additional requests to those already established tests from our customers. So those are very interesting projects to work on. One particular aspect I highlight, since we're automotive or targeting automotive industry, is the crash worthiness of the material, of a structure and of the material. So we actually partner with our customers to come up with a crash program. How we're testing the materials, if it's a triaxiality test that we would deploy in-house or at a agreed, a service provider. We would commit to those milestones.
And from your perspective, I guess, are some of the challenges that your customers or what you're seeing in the automotive space as to the adoption of additive? I mean, I think you guys may be one of the leaders in kind of trying to take it beyond, like, into kind of larger production. But what in your opinion are some of the challenges that the automotive sector is looking to solve, or some of the things that might be kind of on their horizon for challenges that must be met by advanced manufacturing?
Yeah, in the automotive industry, definitely productivity and cost. At this time, I think the MLS is still pretty, relatively expensive technology, manufacturing technology, and the cost and the print rate related to the process need to be significantly improved to compete with the conventional stamping and casting processes.
And on that same note, what does your kind of workforce or your team look like in terms of operating some of these pieces of equipment compared to kind of a typical stamping or machining operation? Is it kind of a different looking workforce than you might conventionally have in an automotive sector?
Like what are we doing to advance the productivity and cost, you're saying?
Yeah, I mean, I guess, what are some of the skill sets in terms of machine operations? What are some of the differences in terms of the kind of landscape of operating a facility where you have a lot of DMLS equipment around? Have you noticed any challenges or opportunities that have come across from kind of developing your facility in that way, since it probably looks a lot different than what you might see in a traditional Ford or GM or BMW plant that you would see?
Yeah, absolutely. I just imagine a farm of 3D printers, and how do we automate, right? Like the post-processing automation is a big area we're looking into, where, how do you effectively um, get the print out, depowder, and remove all the supports, and bring that back, bring that to the assembling cell, in an automated manner. That is an area that we're looking into. Um, in terms of the cost of or actually the productivity, we have a team of engineers and scientists looking into um, process parameters. So, with how do we print aluminum, for example, at 10x the rate that is being achievable, um, you know, in the art, for example. So we do large investigations in how we can increase the productivity, but meanwhile maintain the mechanical properties, and having them being acceptable in our crash requirements.
Sure. And I mean, productivity, print speed is certainly a big aspect of cost, but also are you looking at kind of the material costs and inputs as well, given kind of you have the need for aluminum or other types of alloys, but if you're using DMLS, you have to have them in a very specific particle size or powder shape, usually atomized in most cases. Is that something you're looking into as well?
Yeah, I'm glad you asked. So we are exploring in what are the possible manufacturing techniques. You mentioned atomization, but can we not you know uh, print with super spherical or ultra spherical powder? How much satellite or um, uh, irregular of the powder shape can we live with? Those are cost trades that we're definitely looking into.
And how do you kind of balance all of those different factors when going on kind of your design of experiments to optimize the parameters, where there's the cost element, there's the mechanical properties, there's how well does that work in the machine. Can you talk about some of the prioritization that you've had to think through and navigate over your time at Divergent?
Yeah. So ultimately, it comes down to a number we feed into a spreadsheet. Uh, you know, Depending on the specific application, right? I mentioned, even in a chassis, there are parts where, say crash worthiness is a main concern, whereas other areas, say stiffness, where like the A pillar or B pillar, stiffness is more of a concern. Um, Everything is essentially boils down to dollars per kilogram, and we have a way to convert basically how much power it takes um, um, to operate a process parameter that could give us ductility or crash worthiness or high strength. And right, like both sets of parameters have their own cost per kilogram. And the same idea, same logic goes into materials. If we have a PSD, a particle size distribution cut, that could give us you know um, results that are favorable for one parameter. We categorize that as something like a factor per dollars per kilogram. So those things go into our large trade, manifested in a spreadsheet, and we essentially calculate the cost per vehicle in that manner.
And this might be taking kind of a couple steps back, but kind of why the focus for automotive for the company? I mean, there's a lot going on in aerospace and space in general, and a lot medical. But why was automotive the target market?
Yeah, I think there are a couple of factors. One, our CEO Kevin Zinger, he came from a family in a town in Ohio, Cleveland, Ohio, where I think racing was a big thing, and he grew up with cars, and he's fascinated by vehicle structures and how they're manufactured. Um, but if we look into, I guess, the um, different across different industries. There are many leaders in the automotive industry that have mentioned the cost of platform is very expensive. So, for example, Fiat Chrysler Automotive's late chairman and CEO Sergio Marchionne, he actually published an article called "The Confession of Capital Junkie," that the pricing and the pricing of platforms is too high, and the utilization of manufacturing platforms too low. So one solution would be looking into a multi-model or a new type of manufacturing platform that doesn't cost as much for the upfront cost. And then one way to do that is to, have a tooling less manufacturing platform, and advanced manufacturing like advanced automation and additive manufacturing fits exactly in this portfolio and the solution case. So following what the leaders in the automotive industries trying to advise the field and entrepreneurs. That's why we went into the automotive industry.
And so and this may be completely wrong in terms of kind of how I see the automotive space and many other kind of sectors in the manufacturing industry, is you've got kind of folks that are kind of, you guys specifically, doing kind of building a very advanced 3D printing heavy approach to solve some of these kind of challenges and lightweighting and kind of different approaches to manufacturing. There's the automotive OEMs that are investing in the technology and are trying kind of every type of printer out there to find parts and applications. But then kind of the question becomes, how are they going to manufacture that? Are they going to buy more printers? The supply chain really doesn't seem to be that robust yet to kind of handle a big output or surge of 3D printing specific parts. You guys seem to be setting up to do that and other things, but do you also see kind of in kind of some of the existing supply chain that maybe used to machining or stamping also jumping into additive, or is really going to be kind of taking your guys' approach where kind of entrepreneurs starting from kind of scratch and kind of making these new manufacturing centers, so to speak, that partner with some of the big OEMs?
Yeah, let me try and reiterate the or process what you said there. So I understand that like from reading from the internet and magazines, that many automotive OEMs are slowly adapting the technology in a granular way. So they probably would look at a specific part. Right, Bugatti had their brake caliper. I think Fiat Chrysler just came out with a demo part. It looked like a turbo, but they're looking into replacing a specific application and the manufacturing of that with additive manufacturing. Our approach is slightly different, where we're trying to make the entire chassis, or we're trying to introduce essentially a digital manufacturing platform where we can, you know, build or understand the material, the vehicle from cradle to grave. The entire economics of it, not just focus on one particular application. Um, so I think we're a little different in that sense. And um, the Divergent, what we call DAPS, Divergent Adaptive Production System. The goal is to work with OEMs and have them, basically use our platform to create their vehicles. Um, yeah.
Got it. Okay. That makes sense. And kind of as you've kind of been in the space a number of years, what's something that you've learned or that you would have done differently as you've started out and kind of going down this path, and especially in the materials side? Is there something that stands out that you've kind of clicked or kind of learned to adapt in the industry throughout your own career?
Yeah, I came to Divergent because I saw the power of new materials and the need of it while working at Rocketdyne, um, and maybe influenced by my background in academia. But um, like Rocketdyne basically created their proprietary material, so then they can leverage an entire different engine cycle to bring mass to space. And it's made possible because they were looking into 3D printing technology, and they saw the same challenge that, well, not every part or not every material can be 3D printed. So let's engineer it from the core, right, from the chemistry, ground up. Let's create a new material that's suitable for 3D printing. And I saw the big opportunity or the white space in that work. So I came to Divergent to lead a team to develop new materials. And given my background in aluminum, I saw a tremendous opportunity in, given the current demand for lightweighting, having engineer a aluminum material would be very beneficial for the field. But I think there are so many opportunities still, and white space remain in this area, that I would say alloy development is going to enable a lot more within 3D printing. Yeah, go ahead.
And kind of as we close, kind of what are you excited about for 2021, either kind of personally or through kind of Divergent and some of the new things that you guys are working on?
Yeah, so I can't disclose too much, but this during this I'd say difficult time for many, 2020, with the pandemic. Many companies are heavily affected, but as a tech startup company with a valuable product, people are looking to invest their money, and in maybe non-conventional ways, like the stock market, or other sorts of what we would call, I guess, stable investment. We have seen as a company a huge growth in interest from investors, and that's very positive. So in the next year, in 2021, we're going to actually implement another cycle of growth. We'll be hiring a lot more engineers and scientists to work on our platform to make it better for our customers, and to expand to other people in the automotive industry who haven't had a chance to use our platform. So I'm very excited for that.
Fantastic. Well, thank you so much for joining the show today, and we look forward to talking to you soon.
Thanks for having me, Mike.